Problem 1. A first-order gas-phase reaction, A yields to 3R, is first studied at a constant pressure of 2 atm, starting with pure A. After 15 minutes, the volume increases by 75%. When the same reaction is carried out at a constant volume and the initial pressure is 2 atm, how much time is needed for the pressure to reach atm? So how do we solve for number 1? First, we have to know the available variables that we can use. But then, as we can see the problem, we can solve for it since the k is not known. But we can solve it since it is said that there are variables to solve for k using the varying volume reaction. So, based on the problem, it is a varying volume reaction. So the equation for the varying volume reaction is negative ln of 1 minus delta V over epsilon A V naught is equal to kT. So, how is this formula derived? So, this is from the equation, the rate equation of RA. So, we have RA is equal to CA naught over EA d ln V over dt, which is also equal to kCa. Now Ca is also equal to Ca naught times 1 minus Xa over 1 plus EA XA. This is also from the equation XA, the definition of XA, which is NA naught minus NA over NA naught. Where NA is equal to NA naught 1 minus XA. So by dividing both sides with V, we get this. So we substitute this equation of Ca to this equation. Let's call this equation 1. So substituting this value of Ca to the Ca here in the equation 1, we get Ca naught over Ea times d of ln V over t equals k Ca naught 1 minus Xa over 1 plus Ea Xa. Canceling Ca naught and multiplying this side with V naught over V naught, we get 1 over EA d of ln V dt equals K V naught minus V naught XA over V naught plus V naught EA XA. And we have an equation that defines V as V naught times 1 plus EA XA. So we can substitute V here. So we can write this as 1 over EA d of ln V dt equals K of 1 minus XA over V. So further manipulating the equation, we get 1 over VEA dV dt is equal to K V naught EA minus V plus V naught over VEA. So integrating, we have dV over 1 plus EA times V naught minus V equals K dt. And we will arrive, integrating, this will arrive to 1 minus delta V EA V naught equals KT. So we can use this equation to solve for problem number 1. Using this equation to solve for the problem 1, first we solve for the value of EA. So we have EA is equal to 3, which is the coefficient of our product, minus 1, the coefficient of our reactant, over the coefficient of our reactant, which is equal to 2. So at T is equal to the time equal to 15 minutes, delta V is equal to plus 0.75 of V naught. So substituting these values to the equation we derive, we get negative ln 1 minus 0.75 V naught over 2 V naught equals KT. KT, where RT is 15, we can solve for the value of K, which is equal to 0.03133 per minute. So we can use this equation to solve for the time it reached. E equals 3 ATM. So we are given that it has an initial pressure of 2 ATM. So solving for PA, we use the equation PA equals PA naught minus A over delta N times pi over pi naught, where over 2 times 3.2, 3 minus 2. PA is equal to 1.5 ATM. So, since we have already the value of our PA, we can proceed for solving the time from equation 2. So we have negative ln of 1.5 over 2 equals 0.03133 t. This was the value that we obtained in our first solution. So calculating this, we get a value of t which is equal to 9.182 minutes. So for it to reach the pressure of 3 ATM, we need 9.182 minutes.